Garrett's Vortex series introduces a new detection technology that we call MDMF, or Multidimensional Multi-Frequency Technology. Multi-frequency technologies offer the benefit of blending a variety of detection frequencies together for improved detection on targets of all types. Generally speaking, lower frequencies provide improved detection on larger, highly conductive targets, such as large silver coins, and high frequencies provide improved detection on very small items of lower conductivity, such as small hammered coins and small gold nuggets. Simultaneous multi-frequencies provide great detection on a wide variety of targets, but in addition, Garrett's unique MDMF technology also analyzes the targets and surrounding soil matrix using multiple dimensions of conductivity and ferrous content. The addition of this advanced multidimensional technology provides a more comprehensive analysis to formulate a more accurate target ID, and even at greater depths, in areas with increased ground minerals. As many of you know, in highly mineralized soils, a single frequency detector's target ID accuracy and detection depth are the first things to suffer. Garrett's MDMF technology helps preserve detection depth and target ID accuracy in these mineralized conditions. With the VX9 model, this multidimensional analysis of a target's conductivity and ferrous properties is directly shown by a multi-axis target ID scale. This three-tiered system includes a non-ferrous target ID scale and two different ferrous scales. The center scale indicates non-ferrous items. Low conductivity items such as thin hammered coins will indicate towards the left side of the scale. High conductivity items such as thick silver will indicate towards the right side of the scale. The upper iron scale indicates flat ferrous items such as steel bottle caps and washers. These flat-shaped ferrous items create complex signals that trick many detectors into thinking they are coins. More common ferrous items such as nails and wire indicate on the lower ferrous scale. A bottle cap may actually indicate on both the lower simple ferrous scale and the upper complex ferrous scale. Let me give you a few examples. The lower scale, which runs from the target ID numbers of 0 to 39, is reserved for what I call simple or common iron items. Ferrous items such as nails, tacks, screws, etc. will generally show on this lower scale. A pure non-ferrous item such as a coin will generally show a consistent target indication on the center scale of the VX9. This central conductivity scale maps targets with IDs from 40 to 99. In the case of this silver coin, its digital target ID number is 78. And its target identification aligns with 78 on the scale. Notice that there are no pixels, smudges, or blocks showing in either the top row or bottom scale. The top scale is reserved for tricky or complex iron items, such as flat steel washers or bottle caps. These flat-shaped ferrous items create complex signals that contain both ferrous and conductive components that can confuse some detectors into reading like a coin. With this bottle cap, notice there are pixels simultaneously showing on the central conductivity scale, as well as the upper tricky iron scale, and possibly even on the lower ferrous scale. This indicates that the target is not purely non-ferrous, but one that contains a combination of ferrous and non-ferrous properties. Now, it's important to note that the MDMF technology is an advanced target analysis process that is always taking place whenever your vortex is operating in the multi-frequency mode. Regardless of how this information is displayed on your detector's LCD, the multidimensional analysis is always working in the background on all vortex models. The VX9 model has the three-tiered target ID scale I just described. On the VX7 model, the user sees only two target ID scales, the lower scale being ferrous or iron targets, with the target IDs ranging from 0 to 39, and the upper scale on the VX7 is your conductivity scale, showing non-ferrous targets with IDs ranging from 40 to 99. The entry-level vortex, the VX5, contains only a single target ID scale that runs from 0 to 99, something Garrett users are going to be familiar with who have run an AT Pro or an AT Max or an Apex. As I mentioned earlier, the multidimensional, multi-frequency analysis of the target's conductivity and ferrous properties still occurs on the VX5. It is simply presented in a single scale format. The VX5 user still reaps the benefit of better detection depth and target ID thanks to the MDMF technology. And as you can see, all three models provide a large digital target ID numeral.